I just finished marking the graphs for the rates of reaction, and I think we need to go over how to make a salty graph. Okay, you need to remember that you need to check before submission. Okay, so here is the results table. So I just used the three molarities, zero point 0.1, 0.5, and 1. So as you can see, zero point 0.1 mole took 300, more than 300 seconds. Zero point 0.5, 130, 1 is 7. Now note, look at how I made my results table. I had to make sure that I also included the units. Okay, always include the units, very important, so that people will know what is this 0.1 about, what is this 0.5, what is 1, I don't know. And then you can say, excuse me, ahem, ahem, look at the heading. It's written there, moles, and this one is in seconds. Okay, so that everything is clear and detailed. Now the next thing is, how am I gonna graph this? When you get your papers back, you will see that it has S, A, L, T, and then G and N, S. Okay, I'm going to explain that through this video. So when you make your graph, you need to look at what you are going to be graphing. Okay, so this is pretty easy. We are comparing the amount of time it took for the bong to pop. Okay, and we already settled that we are making a bar graph, not a pie chart, not a line graph, and certainly not a histogram. Okay, so please make sure you know the difference between bar graph and histogram. It was in the other video. The main thing is, when you look at it, bar graphs have gaps between the bars. Okay, while histograms are all stuck together. Okay, and that's for another video. Okay, so for this one, I'm looking at 7, 130, and 300. Okay, so how am I going to do that? Okay, first let's put the line. Now, if you see that the interval or the range is wide, I don't know why you guys insist on making a chart this way. When you have this, you can use the whole length of the paper. So think about that. Logically, you have to look at the paper you're given. You have to look at the size, and then you can figure out, do you want to do it portrait mode or landscape? Okay, it depends on which one has the wider range. In this case, it's this one. Okay, so we have to do it this way. Why? Because in salty graphs, the first thing you look at is the scale, S. And what is scale? Okay, scale. Accurate scales are chosen. The IV, what is IV? IV, come on. Independent variable, and we talked about this. The independent variable is on the x-axis. The x-axis is the line that goes left to right. Okay, independent variable. Now, as I told you, in this table, the independent variable is on the left. So this is your independent variable. So you can see the range in your independent variable is very small. 0 0.5, 1, 0.1, 0.5, and 1. Okay? Now, the dependent variable, which is the right column, okay, is on the y-axis. Again, the y-axis goes up and down. Okay, so this is what goes up and down, the dependent variable. And you see that the range of values is 7 to 300. So it's a very wide range. So why are you going to use this short spot? You want to use the long spot, okay? The length of the paper. So remember, that is your scale, okay? IV on the x-axis that goes left and right, DV on the y-axis that goes up and down. That is scale, okay? So let me just use red pen so that you can see very well, or maybe I'll just use this one. This one is thick so you can see. So I am going to put in my y-axis. Now, A lot of you want to put your y-axis over here. Why do you want to put it at the edge of the paper? Then you won't have any space to put your scale and your label. Okay? Put it 1 block in or 2 blocks in. It's okay because look at your x-axis. You only have 3 values. There is enough space. So I'm going to go 2 in. Okay? So there you go. I'm using my ruler. Okay? Now, when you do this on your own, you need pencil. I'm just doing it with pen so that you can see it clearly on the video. Okay? And I will do my best not to make any oopsie mistakes. Okay, so there you have it. I have my x and y axis. So this is y axis, as we said, going up and down. And this is my x axis going left and right. Okay? Next, so that is S. Now, how do I know that you did the right scale? So I have to wait until I see you label it. Okay? Now, let's look at axis A. What is axis going to look like? Axis, the scale is clearly shown. Even increments. What are increments? Increments, that means your values increase by the same amount. Okay? In the same interval. And there's only 1 0. We talked about this already. I'm just going to use pencil now so you can see. Some of you, along the years, okay, I'm happy I haven't seen anyone yet, put 2 zeros. That is not correct. You cannot have 2 zeros. The 0, okay, is where the 2 axes intersects, okay? And it intersects here. So that means there is only 1 0. Okay? 1 0. Okay? Now, how do I make it increase? How do I make my increments? So I need to look here. Okay? So if you look here, let me put this away. 7 to 130. That's about, okay, not just about, it takes 123 values, okay? Needs to go up by 123. Okay. And then let's look at the next one. 130 to 300. So that's about how many? 170. Okay, 130 to 300 is 170. So you can see this is about 50 more than this. So when you do your break in the axis, okay, that's the mathematical term for the squiggly line, break in the axis, because the values are so far apart, okay, the distance between these two and the distance between 130 to 300 should be a little longer than this because it's 50 more. Okay? So let's do this. Okay. Now, I can put in, let's say, now some of you are doing this. You're just putting numbers randomly. When you do that, I don't know which one is 1, which one is 2, 3, or 4. No. Put a line there and give it a value. Okay? Don't just randomly put numbers. That shows me that you don't know what's happening. Okay? So what I'm going to do, I'm going to make this value 10. Okay? So 1 block is 10. Okay, so where would 7 be? Okay, if 1 block is 10, that means each of this would be equal to 2. 2, 4, 6, 8, 10. And where would 7 be? 7 would be between 6 and 8. Okay, so if that's 2, 4, 6, 8, then 7 would be somewhere there in between 6 and 8. That would be 7. Okay? Now, why am I squeezing it in here? Because I put the table here. I don't have enough space. If I had enough space, I would put 10 over here. Okay? Now, let's see. Now, the 10, okay, I need to go from 7 to 123. Okay? So, I'm just going to assign 1, 2, 3, 4, 5. Okay? So, 1, 2, 3, 4, 5. This would be, okay, I'll give it 130. Okay? So I have my second value. Now, how do I go up to 300? I'm just going to add some more, okay, so that we can have almost the same interval. So this would be 140, 150, 160, 170, 180, 190, 200. Now look at that. I went up, but look at my gaps, okay? Each block has 10. So look at my increments. I went up by 10. And the interval on the graph is 1 block. So 1 block equals 10. That's what we mean by uniform intervals. Okay? The distance between one number to the next is equal, and uniform increments. I increased it by 10. I'm following this. 1 block is 10. So after my squiggly line and I have 130, or sorry, break in the axis, okay, I have 130, so it needs to go up the same increment by tens. It's up to you. What do you want? Do you want two blocks, 3 blocks? But it has to be the same, okay? Now, from 200, so I started 200. I need to go 300. That's about 100, okay? So if 5 blocks is 123, then 100 would probably be 1, 2, 3, 4 blocks. So I do my squiggly line again, and then this would be representing 300. Okay, because this one represents 120. 1, 2, 3, 4, 5. And then this one, 200 to 300, is only 100 because I started here. So that would be smaller than this. Okay, so that's how you do your squiggly lines. Logical. Don't just blindly put a lot. Okay, and the squiggly line, okay, don't make it like so many. Okay, just 1, 2, 3, 4. We know that there's a break in the axis. Okay, so can I give you a mark for this one? Scale is clearly shown. Even increments, okay, went up by 10. And interval is uniform, okay, 1 block each, only 1 0. So you will get a tick for that. Okay. Now, let's go to the next one. What is the next one? L. L is for label. Okay. So we need to identify the data, including the units. So this has something to do with the scale, because IV and DV, IV is on the x-axis, DV is on the y-axis. Okay. So what am I going to put on the x-axis? I need to identify, and I know the x-axis contains the independent variable, and the y-axis contains the dependent variable. Some of you, my goodness gracious, just copied what I said and put DV there and IV here. That's not what I mean. Do not take it so literal. Come on, let's think a little bit. I'm giving you a clue. I'm telling you that the x-axis, you need to put the independent variable. The y-axis is the dependent variable, but you have to tell me exactly what the IV and the DV are. So in the rates of reaction, just look at the table. There is your IV, there is your DV. And all you need to do is to copy it to the graph. Okay, so what is my IV? The IV is molarity of HC and small l. That's it. And I need to put the units in moles. Okay? Now, what is the dV? The dV is time it took bong to pop. And I put the units in seconds. That's it. Okay? Now, did I identify the data? Yes. I told you what's on the X and Y axis. Did I include the units? Yes. Moles and seconds, which is exactly in your table. Okay? So do you get a mark for label? Yes. Do you get a mark for scale? Did I put the IV on the X-axis? Yes, I did. Did I put the DV on the Y-axis? Yes, I did. So do I deserve a mark for the scale? Yes, I do. Okay, so there is my tick mark. Wonderful. Last, okay, title. Explains the purpose of the graph. What does the graph show? Okay, now I told you the title cannot be a question, and the title needs, since this is a science experiment, you need to add the IV and the DV in the title. Again, IV independent variable and DV is dependent variable. For those of you who asked me, how do I write the title? I have a secret. The title is based on the testable question. Okay, now let's go down here. What was the testable question? Okay, what was the testable question? The testable question says, how does the molarity of hydrochloric acid affect the rate of reaction? Okay, testable question. But you cannot have a testable question for the graph. So we need to change the testable question into a statement. Okay? Statement, that means it ends with a period. Okay? That is the sound a period makes. So, how will I make this into a statement? I will just remove this part. Okay? The effect, sorry, that's E. The effect, okay? So this table shows us the effect of the molarity of HCl on the rate of reaction. Okay, explains the purpose of the graph. So this graph is telling me the effect of molarity on the rate of the reaction. That's it. Do I deserve a tick on the title? Yes, I do. Okay, now what is the G? The G is if you use the appropriate graph. And did you draw it properly? Okay. Okay, so we start here. Point 1 is all the way here. Okay, and so I will put this one down here. And I will label it point 1 because it's for 0.1 mole. And I will put on top more than 300. Okay. And then let's do 0.5. 0.5 is 130. So that would be here. So you will notice I left a gap between the bars, but not a significant amount of gap. Some of you put one bar here, the other bar here, the other bar here. Why? Okay. So this would be 0.5. And the last one would be, okay, 7, okay, which is for 1 mole. So this would be 130 seconds and this would be 7. It's just nice to mark it so that it's easy for the reader to see. Okay, now you can use highlighter. Okay, like I'm gonna use highlighter to color it or to put patterns. Okay, so this one I can put this type of pattern. Okay, there you go. And then the other one I can just use a different pattern, maybe the opposite. Okay, if you have the same color, use different patterns. And this one I can just put across. Okay, it's up to you as long as I see differences. Okay, so do I deserve a tick for the graph? Yes, I use the correct graph. I use a bar graph. Okay, my bar graph is correctly drawn. There are gaps. Remember, there are gaps between bars. Okay, and I put in the correct amounts. Okay, so I would give myself a tick. Now, what is NS? NS stands for neatness and spelling. Okay, now if the only thing on this paper is my graph, I would give a mark for neatness. Okay, the only reason it looks a bit messy is because I was scrolling notes here. But if I only had the graph, and the title should be above the graph, not inside the graph. It's just that I didn't have space. Okay, so this title should be above here. So if it were a separate graph on a separate sheet of paper without me giving this tutorial, yes, I would give myself a tick for neatness. Spelling. A lot of you already saw this. It's in the paper. Why can't you spell molarity properly? I saw spelling morality. Morality is a word that's different, has a different meaning from molarity. Some of you put morarity. Okay, it's a formal document. Please spell correctly. Make the effort. Make the effort to spell correctly. Okay, now, so this is how to make the graph for the rates of reaction experiment. It took a little bit longer than expected, but I wanted to make sure everybody knew how it's going to be marked. Okay, any questions you can ask me in class tomorrow. Bye-bye.